Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So welcome to the section on data-intensive science. And we have two speakers. We have Professor Masaru Yarime, ready to go. And then it will be followed by Professor Shuichi Iwata. Okay. I'm told that Japanese and Italian, we pronounce in the same way. Okay, so Iwata should be close to good with the pronunciation. Okay, fine. So, stopping wasting everybody's time, I let Professor Yarime to go on with his presentation, which is analyzing the process of knowledge dynamics in sustainability innovation towards a data-intensive approach to sustainability science. Very good.
Okay, thank you very much, Mr. Chairman. My name is Yarime Masaru. I'm an associate professor in the graduate program in sustainable science of the University of Tokyo. Frankly speaking, I'm not an expert on this data science or computer science or the other information or data-related disciplines. But my original background was chemical engineering, and then I studied the economics of technological change and innovation studies. So my interest has been on how to utilize this data information knowledge, or different types of data knowledge, to promote innovations in society, with a particular focus on sustainability. That is what I'm now working on. So basically, this is not so much about the final result of my research, but rather just a rough idea with regard to what I'm interested in doing in the future. And I'd like to receive comments and suggestions and your help if you could provide in any sense. Well, with regard to sustainability, obviously that sustainability deals with many different issues, like the environmental protection is obviously one of the main issues, but also the public health and food security and water and others. And so the sustainability essentially concerns many diverse issues in society. And that means that you need to deal with very different types of data with a vast amount of data, and they range from natural environment, natural systems, and also artifacts in society. So that is the huge challenge to people working in this area. And then that now we are now trying to propose and trying to develop what is called sustainability science. And obviously, the sustainability science needs to cut across different academic disciplines and natural science, obviously, and also social sciences, engineering, and humanities. So, perhaps you might never heard of this idea of sustainability science, but this has been proposed, let's say, at the end of 1990s and the early 2000s. Basically, that we try to deal with the complex and the dynamic interaction between natural systems and the social systems with regard to sustainability. So essentially, you require to deal with natural sciences and social sciences. And then that somehow that we try to deal with these systemic characters of these interactions, a complex and dynamic interaction between natural phenomena and social phenomena. So, there are some people working in this area with a team of natural scientists and also the social scientists. And then they at least try to deal with some common elements, common characteristics with regard to the interaction between natural and social systems. So they try to identify this nonlinearity and the reciprocal effects and time legacy effects, and these are the common elements found in these interactions. So one approach is to try to deal with that is to try to focus on the narrowly defined geographical areas, and then to try to understand in details the flow and interactions of energy, materials, and economics, and also perhaps in some cases, social values. So that is one approach to try to define a very small area and then try to analyze in detail and to track or trace the flow of various types of exchange and communications. With regard to sustainability, that one essential element is time dimension or temporal dimension. So in dealing with sustainability, we need to try to understand the process of change, the time dimensions. That is has been originally proposed by the Brundtland report in 1980s with regard to sustainable development. So that needs to be the focus of sustainability science exercise. So although there are many ways to understand the process of change with regard to sustainability, but one way of looking at is to try to understand how the knowledge in here defined in a very broad way and very loose ways. So I somehow use data information knowledge in a more inter-exchangeable way. So we do not are not so much interested in this making a precise definition in these different terminologies. But basically that we somehow need to understand the social process of knowledge dynamics in sustainability. That is one approach, and this is what I'm now interested in this area. So, because that is somehow very critical in promoting the innovations for sustainability. Because to look at the case of climate change, it's obviously that we need to have many types of different innovations to reduce CO2 emissions, which means that you need to reduce energy consumption. So you need to adopt the renewable energy technologies and others. So that is essentially for understanding and promoting innovations for sustainability. Then, these are some of the discussion in innovation studies, but the basic idea is to make a shift from individual attributes to systemic characters. So to understand innovations, you need to somehow move beyond the characteristics of individual researchers or individual companies or individual countries, and that rather going into the systemic elements, which means you need to essentially deal with the interaction between different organizations, different the entities, different the peoples, and so that is somehow become the focus of innovation studies. So particularly in the case of sustainability innovations, that is essential because you need to deal with different types of data information regarding different aspects of sustainability. So then to understand the innovations, then you can deal with this structure, functions, and dynamics with regard to systemic approaches to innovations. Where then the structural components could be identified by three elements, like knowledge domain, which means issue specificity, because each issue has its own specificity with regard to what kind of knowledge are involved. And then the actors, what kind of actors are relevant for making innovations, and then institutions which are surrounding the actors and the knowledge specific to that particular issue. And then going into the functions of innovation systems, perhaps there might be other ways of defining different functions which are necessary to produce and then promote and diffuse and utilize these innovations. There are several functions. One could be entrepreneurial activities, because you need to have at least this experimentation to create variations for different types of technologies. So that obviously you can think about that with regard to the evolutionary theory in biology. You need to have variations. So in innovation, you need to also have these functions. This is essentially niche experimentation. And then the second function could be knowledge development. You need to develop some experimental idea to have more solid knowledge, which are normally conducted by R&D activities. And then the third one is knowledge diffusion. You need to diffuse that kind of knowledge into relevant actors. So you need, in this case, the networks and collaborations are the patterns and the structure would be very important. And for the guidance of search, this is a bit different from others, but somehow you need to consider the influence to which directions the search could proceed. So in this case, probably the societal needs and also the societal requirements would also have a significant impact into the direction of search. And the fifth is market formation, because you have this niche idea or very infant ideas, but you need to bring these ideas to the mainstream society, because that's somehow it's a definition of innovations. So you need to have a kind of in a broad sense, the business model. It's not purely the private activity, but also you need to create a business model in society through collaboration between the companies, universities, and the public sectors. And the sixth one is the resource mobilization. You need to have this kind of bringing these niche ideas into market to the mainstream, that you need to mobilize different types of resources. One could be human resources, and also obviously you need to have the financial resources, and obviously the physical resources is also important. So you need to have these functions of mobilizing different types of resources to bring forth the innovations to the mainstream society. And the seventh one is legitimization, or creation of legitimacy, which means that once some new technologies is brought into society, but this technology needs to be accepted somehow by stakeholders in a broader sense in society. So you need to have somehow have this function of how to create legitimacy for that technology. So at least these different types of functions are necessary to have, to produce, and then to develop, and then to utilize innovations in society. So the implication is that you need to deal with these different types of information, data, and how we could collect, manage, combine, and utilize by which actors, and by how, in what kind of institutional conditions. So these are my questions, and at this moment I don't have any answer to that, but at least I'm now trying to work with my students and colleagues to try to materialize these ideas in some specific cases. Well, then going into this data, because this conference is about data-intensive science. So, to operationalize these functions of university system, that you need to identify in more detail it's what kind of data information you need to collect and assemble and utilize. So with regard to the number one, the function one, the entrepreneurial activities, you need to identify the types, numbers, activities of entrepreneurs. Obviously, it's not so easy, but at least you need to have this kind of data. And then the knowledge function development, that again, that you need to have data on types and numbers and activities of organizations performing research, which could be basic or applied or more commercial-oriented type of research. And then that when that research project started and how long and when it's finished. So these kind of data would be important. And third one, the knowledge diffusion. Then this could be essentially dealing with the collaboration and cooperation and networking. So R&D organization could cooperate with together, and also researchers individually could cooperate or have a network together. And also with regard to knowledge diffusion, there are many research now going on the bibliometrics analysis. So you could use the citation network of papers, and that could be the area of the recent very active research area in this field. So you could use this knowledge, purely knowledge type networking. And then the guidance of search, then this could be including that different types of targets set by industry or government or markets, and also the technological expectations maintained by the stakeholders and society in general. And also, the government regulation could also have a significant impact on the direction of search. So this is particularly the case in the field of environmental protection and food safety, and also the safety and disaster. These are the areas. And the fifth is market formation. In this case, this is more closely linked to private corporate activities, and obviously that commercialization of products and market size and financial channels and market demands. And these are the at least some of the factors and conditions you need to deal with in understanding this function. And then the sixth is resource mobilization. Then, as I said, that this includes raw materials, physical resources, and the human resources, in this case, the research personnel or other personnel relevant for innovations, and also education programs in society. You need to provide human resources in society in general, so you need to have some educational programs and institutions to provide these human resources. And also the venture capitals. This is also quite important for particularly the rapidly emerging technological areas. And then the legitimization or creation of legitimacy would involve the data on, again, the types, numbers, activities of advocacy coalitions. This is the terminology used by political scientists. And normally that different actors have different incentives and different interests normally, but sometimes that they could make coalitions to have a common targets regardless other interests. So normally that in political arena in particular, that it is very important to identify the formation of coalition advocacy to push a particular agenda into the political process. So broadening that concept that you could have this kind of, even though it could be loosely connected coalition, but still you could identify this kind of the social coalitions with regard to pushing, accepting, or rejecting particular technology. So this will be the case in the case of GMOs, genetically modified organics, and also the nuclear technologies. So this could be quite important. So again, the data information on these kind of activities you need to identify to understand this function of legitimization. So perhaps I have about 5 minutes. So well, this is just basic idea, and then I'm now doing so. So this is just the beginning, and also I have entered in this field of data-intensive science and areas not so long time ago. So I've been working with my colleagues, and this is an example of the case in the Chinese innovation systems on membrane technologies. We identified one particular technology, and they try to somehow get collect and measure these different functions by using available data. So entrepreneurial activities, you can identify some of these different companies and then how they conduct some experimental R&D activities. Then the knowledge development, you have this paper publication by using database on this is ISI Thomson database Web of Science. Then citation analysis. This is more closely linked to the knowledge diffusion. But you can also use patent analysis. This is also a well-established database, particularly in the case of US. USPTO has maintained the database since 1970s. So it is a very important source of information of patents. And then knowledge diffusion. This could be collaboration between different types of organizations on R&D, and also exchange of information through journals, and also the conferences and exhibitions. So then we could try to get data on this, what kind of people attended these conferences, and how they formed a group on the research consortia or research group. So you could use a network type analysis based on this data. This is a network of the co-authorship of articles and papers. So this is essentially means that these co-authors exchange knowledge or share the same type of knowledge. So this could be the function of knowledge diffusion, and then guidance of search. Where in this case, this is about the water pollution, or water scarcity in China. So obviously the government considerations for the water environment is very important in this case. So you could try to collect some information on these kind of different types of the regulations and the support by the public authorities. And then the market formations, you have this data on the market sales of technologies. So this could be not so easily available compared with papers or patents, because they are well established and more neutral type of database. But in the case of commercialization, it's not so easy, but still you could utilize some the data maintained by the private companies or consultancies in this area. Then the resource mobilization. Then you could get data on how much money is introduced into research activities, and probably human resources, which somehow needs to have data on what kind of educational programs and the graduates are produced by which university, when and where. So this is again the data you need. And then the final function, the creation of legitimacy. Again, this is not so easy, but at least in the case of environmental regulation, that you could somehow argue that if you comply with the regulation, then this could be at least officially legitimized, although still there are many different issues which are rejected by the consumers regardless of compliance with regulations. But still, this is one way of looking at how the legitimacy is obtained. So, well, then that I'd like to have a kind of dynamics of these different functions for making producers, but this is still not well developed in this area. So, a slightly different way of looking at the innovation is to look at different phases, not so much as functions, but different phases through the process of the issue linked to sustainability. So you have emergence of an issue and the recognition of that issue and scientific research and technological development and impacts in society and feedbacks from society. So then again that you need to deal with different types of knowledge and data, natural science and also media and also the behavior of scientists and companies. And then the impact society includes LCA type analysis, and then to feedbacks from society to the behavior of the scientists. So this could be the dynamics and the cycle of knowledge and information. So well, I don't have enough time. So you could identify different types of the data knowledge for different types of innovations. So at this moment, I'm trying to have a system of innovations for different fields. I do not have so much the conclusion which could impress the audience today, but well, innovation dynamics you could think about for different the innovations, and then you could identify different functions, or you could say different phases, but different types of actors' knowledge are relevant. So implication is that how you could collect and manage, utilize these diverse types of knowledge effectively and efficiently for making innovations, because that is the interest which normally the people have in society in general. So you need to have tools, practice, incentives, and institutions. And these are not so much about the technology per se, but rather the social kind of social technologies with regard to this data collection and data utilization. So the last one in industrial dynamics and industrial ecology means that the incentives and also the desirability is not normally the same. So the company is working with regard to the pressure from the financial markets and also the shareholders. But then that doesn't necessarily means that that is good for society. So again, the different types of data knowledge are relevant for incentives and also social impact. So again, that is how we could combine these different types of data, knowledge, information is a big issue. This is the end of my presentation.
Okay, thank you, Professor Yarime. Okay, I think we still have time for a couple of questions. I also have a question myself, but I don't want to take privilege of my position, so I ask the floor first. Is there any question? Yes, please. I think you're asking my question.
Okay. Yeah, I'm just wondering, like, how you define.
Yeah, it's saturated.
Okay. My question is, how do you define the data intensive aspect in terms of like size, or in terms of petabytes, terabytes? Do you see that that if that's relevant in your research?
Well, yes, obviously that should be relevant when you conduct research in the concrete terms, because you need to deal with some type of data. But as I said, I'm not yet achieved the level of conducting very detailed analysis with the vast amount of data. But at this moment, somehow that we are working together with my students, and some of them are conducted manually, actually. So, but I hope that if we could employ some sophisticated technologies, and well, we know that the databases are available for at least for papers and patents and some other databases, but not for others. So first, we need to identify these databases, or how we could collect these data from different sources, and then how we could process these data, and then how we could combine or integrate these different types of data. So that is what, frankly speaking, I don't know at this moment. So this is my opportunity to try to learn from others in this kind of meetings, and then that is what I'm now here to present my just preliminary ideas.
Okay, other questions? So then I can ask my question. The first is a comment. I do believe, and I think your talks and the question here confirm that it is indeed data-intensive research. Because if you really want to correlate information that are spread on economic database, social database, etc., you need a lot of data fusion, a lot of search, correlation. So my comment, yeah, that actually your talk and your research fit very well in a data-intensive track. Now, the question is another one. Well, you emphasize many times the non-linearity of the research, because you have so many kind of effect, which is difficult and definitely non-linear. But in general, how do you take into account the irrationality? I mean, all those models, I think they suffer from a major problem that, you assume a kind of an ideal world. For instance, you have a model, you can make a model, a prediction how the stock exchange work, etc. And then you get Mr. Madoff, who comes there and, blow any model, because how do you really factor in, criminal behaviors, irrational behaviors, everybody that get excited for the wrong product just because it's cool, all those kind of things. I mean, it's very, very difficult, I think.
Irrationality of the behavior.
Yeah, rationality of behavior, or criminal. In a financial system, we've seen that few criminals can perturb the entire system, and all the prediction
Yeah, well, well, at least in the mainstream economics, and then they try to explain irrationality rationally.
Okay.
That means that the way that you could understand somehow. So the why people commit crime is because of that. The benefits of committing crime is bigger than that not committing crime. So these kind of explanation is normally made by economists. So somehow, but at least some part of that, well, maybe it may not be irrational, but unsocial behavior could be explained by some rational explanations, meaning understandable to people. But some other behavior, some other aspect of behavior, simply we can't understand. But then that maybe in that case that the data-intensive or data-driven approach might be relevant because you can't explain it, but somehow you could find some patterns dealing with these large amount of data. Okay. Then perhaps that you could contribute to this kind of
okay, so that's maybe also, Corey, of the feedback loop you are describing, where maybe rather than an analytical approach to this kind of problem, more an empirical approach, maybe some kind of machine learning approach, yes. And you can pull out from just looking at the data, you know, those kind of patterns. Okay, I don't want to steal too much time from the next speaker, so let's thank the speaker again. Thank you very much. And now let's give the floor to Professor Iwata-san. And the subject of his talk is data-intensive science for safety, trust, and sustainability. So, Professor, the floor is yours.
Thank you. The title of my talk is Data-Intensive Science for Safety, Trust, and Sustainability. And in case of safety, I'm thinking about nuclear engineering. And about trust, I'm thinking about the uncertainty and reliability of data. And sustainability is one of the target later. And outline I plan to speak, but a little bit I changed. And all the things are written in the abstract that you have in the report. And at first I did speak about lessons from history. And you may know the big Buddha in Nara. And do you have a pointer? Yeah. Okay. You have it. This is a real photo, and this is a virtual photo. And also this is a photo that you can walk through in a 3D way. And this kind of thing becomes possible, and and there are many virtual reality technologies are introduced. But today I don't want to speak about the virtual reality technology, but I want to speak how to produce or how to make large Buddha. And the large Buddha is a kind of metaphor of big database or big information system. And it is data-intensive contents. And please change the word Buddha to large Buddha to big database. And in case of large Buddha, the 745 casting was started, and it was, at that time it was just very awesome. Okay, thank you very much. Yeah, this is the starting of the production, and at the end there is a ceremony to open the to celebrate the fact that Buddha opened his eyes. And afterwards, we need to prepare the big house. And it is like a database management system or some sort of new kind of entity system or other kind of system. And this big Buddha destroyed due to earthquake and fire due to internal fights, and also due to strong wind. And afterwards, two monks had been eager to rebuild that Buddha. And the last one, Kokei, went to the general to support, to reconstruct the large Buddha. That means how to maintain the big database. And the answer from the general is as you like. And you general support spiritually, but they don't support, they don't give them money. And they need make efforts by themselves. And afterwards, they had made a very good business model, how to rebuild a big database and how to maintain the big database. And afterwards, Buddha opened his eyes again, and also he got his house again. And the story is, in the beginning, this is an emperor who initiated the construction of the Buddha. And this is just government. Government funded Buddha has become Fox Buddha. That is the story. And how to make the fox, how the folks make the Buddha. And we need some key persons. A few key persons initiated actions to move the world. And reuse of fragments. This time, the pieces of destroyed Buddha are used to get the funding. And that it had some sort of spirit of the Buddha, and the people think that it is worthwhile to donate for that kind of fragments. And in the fragments, the Buddha small sculptures are encaved. And so the reuse of piecewise data is very important. And also, in that case, new challenges, and how to bring big trees from the beams, for the beams and the columns of the Buddha house. And in that case, there are some technical innovation. And to bring the big beam by ship, it's very difficult at that time. But they invented some new methods, and they have succeeded to do so. But the more important innovation is social innovation. And the monk encouraged the people to work together to make the Buddha. And when the big tree arrived in the shore, then it requires huge powers, and over 100,000 people work together, and it's like a ceremony. And building a database is like that. And to share one mission, then the people can enjoy working voluntarily. And so that is some sort of story of large Buddha. And so I use that story as a metaphor. And in case of materials data, this one I tried to demonstrate this time, but for a while I couldn't do so. But in case of material data, I have started my work in 1970 and made mistakes and made failures and getting budget, but every time within 3 years or 5 years it is cutted, and afterwards we decided to organize an international project. And in this project, I organized a team of best experts in the world and most effective persons. And then we prepared a very concrete milestone how to build materials database. And our target is to digitize all the data that is published in 20th century and on materials. And we set up some constraints that if well and explicitly defined high quality data, we accept that one in the database. And we selected over 130,000 articles and digitized all the data into the computers. and I can bring by the PC now. And in that case, the main point is how to increase the quality. And in case of physics, the one rule is enough to check the quality, but practically we need 200 filters to check the logic. And so the data can be done, but the data part is very difficult to realize. And in this case, the order of length, the differences in the length order is over 10 to the 10th. And in case of time, it is over 10 to the 15th. And even by the best visualization tool, it is very difficult. And we need to take into account the rule and some models. But the most difficult part is experts to one region or one domain. And there are some tendency that experts don't want to talk to each other, or expert is not the person who can bridge the gap between two domains. And domain-dominated experts. There are many domain experts, but not so many experts to bridge different domains. And this is one of the results what I will show you by demonstration. And in this case, all the published data are mapped on materials are mapped in this sheet. And in this case, this is the element in the sequence of Mendeleev number, and also this is the element in the sequence of Mendeleev number. And in this chart, we can map all the data for the binary compounds. And if we carry out some ordering, we can see some sort of solution, or we can find or we can discover some patterns. And if we can have some patterns, we can define knowledge to each region, and afterwards we can predict something based on this kind of maps. And this kind of thing can be done only by the collection of data of highest quality. And by this kind of thing, we combine data and models, and we can derive some solutions. And this is, today I learned the identity, and I have some sort of wish to rewrite all the data by Microsoft infrastructure. And this is some sort of idea to create the world materials data system. And in that case, almost, I think, 1 million experts and students may use this kind of data system as materials user, and also materials researchers and engineers. And we need some distributed environment, and also we need some possibility for the discovery of something. But if we can carry out some highest quality control, we can bridge the gap between the data blocks, and also we can find some new rules by manipulating the data. And this is some sort of part on data. And next part, and in this case, we need strategy to bridge the gaps. And but I think we can do as if we have a set of persons who wants and who can do. And the next subject is a little bit difficult. And energy, environment, economy, and ethics, and engineering, and climate, if we take into account this kind of very difficult issue, we need to solve the problem of uncertainty of data. And some experts predict that uranium is available every time, and we don't need to pay attention to the shortage of uranium. And I'm not sure whether it is. And also this is a change of the oil price in 2 years, about several years ago, and it is very dynamic. Economists can explain afterwards, but they cannot predict. And there are some uncertainties. And this is a collection of all accidents before the 1970 in the nuclear field. And same accidents happened even in Japan. And it is a critical accident, and we are very much surprised. So people are easy to forget. And so in case of oil, this kind of thing is said, and politicians is responsible to the result, not to the theory. And but United States people are very happy that you have only this number of presidents. We, Japan, has too many prime ministers, and we cannot write as a cartoon. So, and how much we can derive something from open data. And if we say that the politicians are intelligent and wise enough and they can lead the people, but there are some uncertainties, but there are some feedbacks. And so, but I think 2 eyes are not enough to evaluate something, and many eyes are very important. And so this is a trial how to improve the quality of uncertain data. And I organized the exhibition in Natural Science Museum, and I collected all the information about nuclear field that is available in the internet. And from that data, I derive some important conclusion. And I don't go into details, but in this case, it is not a description about physics, but E is energy, economics, ethics, and entertainment, and many things. And equal is science or academics. And M is mass flow. And in case of mass flow, it's enriched uranium, plutonium, and also waste management. And in case of climate change, the mass is a problem. And C is a definition based on the code data. And so in this, I really want to explain about how to create science or how to create the academic domain, but I have not time to go into that one. But all the information step by step becomes open, and this is some sort of total amount of plutoniums occupied or owned by different countries. And by using available information through internet, I prepared some chart about all nuclear reactors in the world after from the Second World War. And this is a collection of 3 million documents that is digitized by IAEA. And all the statistics are prepared, and all these charts can be used as indices to reach each real objects. And so by taking advantage of the open data, we can derive many solutions. And in this case, if it is combined with oral history, that can be implemented as an extension of YouTube. We can connect different information in a systematic way. And in this case, 4-dimensional or multidimensional articulation of issues are very important, and that can be, or that is feasible if we take advantage of the Microsoft software or Google software, I don't know. And so anyway, we can discover many things even from fragmented data, but we need to be more perfect to go beyond. In case of nuclear, one Chernobyl accident stopped all the nuclear reactors in the world about 15 years. And so in case of nuclear, we need to be perfect, and we need digital technology. And huge and also very deep semantics of data has been day by day or second by second piled up. And so we need to establish a technology how to deal with such kind of tons of data. And so this is some sort of repeating of the how to make a Buddha and how to. So I want to rewrite this kind of thing to the thing what we can do together. And we have candidates for leaders to move the world. And we have tons of fragmented databases and knowledge bases, or that means contents prepared by government-funded data. And government-funded data should be open at least to taxpayer. But there are some stakeholders that want to keep all the information classified. But anyway, government-funded data should be open to everyone, and it should be used as a public goods. And 5 minutes or about. And we apply some approaches of environmentalists, and they usually used to say that rethink, reuse, and resolve, and recycle, reduce, repair, and reconstruct. And I would say that rethink about the data, and there are huge amount of fragmented data, but they are not well used. And there might be a possibility to use if there are requirements matching, or the matching between users and the producers are okay. And also, if we resolve each complex data into a collection of universal knowledge, then we can reconstruct and recycle, and also we can produce something in a creative way. And so, but to do so, we need theory. One theory might be concerned about the uncertainty or correctness of each fragment of data, and also some tools how to deal with heterogeneous information in a practical way. By experts, it could be done, but I'm amateur to deal with data, and sometimes all the tools, it's not so easy to use. And also we need folks to work together, or we need to become folks working together. And we need missions and incentives like the case of Big Buddha, and we need coordinators who can see different contexts and show a proper direction for each context to overcome expected tons of barriers. Many people say there are many barriers, but it is just the barriers, and we can overcome. And Buddha for us now is safety. I'm just focusing the knowledge sharing of extracting values and avoiding risks of nuclear issues and challenges. Knowing and not static data, but knowing from data is very important to increase the efficiency of people's productivity. And also, we need to pay attention to all aspects of human dimensions. And nuclear forensics becomes a hot topic, for example. And trust, bridging users of materials and producers of materials data-centric of materials data is very important, and where scientific challenges are in making and structuring bridges rather than many meta knowledge or metadata, and how to bridge. And also sustainability, how we can, there are some saying that there is no science, but there are only scientists. And but we scientists need to contribute to the society, and how can we scientists survive? So now it is a conclusion. Let's work together for survival as scientists and as data scientists. And thank you very much.
So we don't have that much time left. I mean, it's the nominal end of the section, but of course, after such an interesting presentation, really all welcome some question, comments. I think, the subject is pretty important indeed, and definitely a good example where, data-intensive science can help to survive. Tony?
Yeah.
About nuclear reactors, nuclear fuel, and so on. What practical steps could someone like Microsoft do to assist that?
Yeah, as in the beginning, we are trying to establish a network of museums, and there are many old legacy of nuclear science and fields, and also documents as like nuclear science abstracts. DOE have prepared, have been doing a very excellent work recently. They have digitized all the information from Second World War to 1970, as if they are important, but that is very important. Its implication as a knowledge or wisdom is very huge, and that kind of digitized data should be resolved into a collection of basic knowledge that can be transferred to some countries, like the new countries who want to develop nuclear reactors, and all the information can be linked by oral history and digitized information and facts, or the object that the museum keeps. And people need to have a look of each object directly. But to guide them to each object, we need some very important a very flexible infrastructure. And also another thing is, we need information technology, as all the object has used to have radioactivity, and we cannot reach sometimes, and we cannot keep in the museum. And some facts are distributed in the world, sometimes in Russia and sometimes in India. And these kind of things are to be integrated as public goods or as a public buds, and for the society. But I think there are some possibilities. If without such kind of thing, we cannot solve the problem of oil peak, and we have some mission. And so in the beginning, I don't try to promote nuclear, but I think the first step is to link all available information in the world for the next generation, and that is it.
You know worldwidescience.org. Worldwidescience.org. It's an organization which could do the sort of thing that
Yeah.
you're discussing.
Yeah.
Okay. Yes.
Well, based on your experience for 30 years or more,
Huh?
your experience in your field for 30 years, and you mentioned that it's very important to make a bridge between different people, different domains, and different organizations. But there, you said there are many barriers. what is the most difficult area in your experience?
Yeah, it's a selfish incentive. But, yeah, scientists also, they want to get the budget and they need to apply and they say they are the best in the world and afterwards, but the real outcomes, sometimes best in the world and sometimes it is forgotten later. But for the smooth inheritance of knowledge might be realized in the education. The bridging the generations is very important. To bridge the generations, information system is very important. And so in case of materials, we are losing experts in Japan. And also in UK, they are discussing seriously, they are losing experts. And so after losing experts, there are some possibilities to make big accidents in airplane, train, car, and in many places. But important data are to be passed to the person in an understandable way, in a good timing, and also in a selected way. And in that way, in that kind of thing, we need a good tool to make an information service.
I think it's a very good comment. So it's important to preserve the information,
Yeah.
but also to present it
Yeah.
in a way that the end user, the
Yeah,
decision maker,
yeah.
has the right
Yeah.
information. Okay, I think it's probably a good comment to close this section. So thank everybody for participating, and let's thank both speakers again.
Thank you very much.